Hello, everyone. Welcome to our show, Spin the Career Wheel with Nikkhiel Malhottra. Today, we have with us Lucian Hiss, Faculty Executive Director at UNSW Engineering. UNSW is a world-ranked top 20 university, and UNSW Engineering Technology School is ranked number 1 in Australia. And today, we are going to talk about how core engineering branches are reinventing future. So come join us in this discussion. Hi, Lucian. Welcome to the show.
Hi, Nikkhiel. Thanks for having me here today.
Thank you. So, Lucian, for years, engineering in India has been known by computer science and information technology. But because of the global movements like transitioning to a net zero 2050, smart cities, EVs, even space exploration, it seems traditional branches like mechanical, civil, electrical are making a strong comeback. Why do you think this shift is being made?
Nikkhiel, that's a great question. I guess I'll start with historically thinking about computer science and IT and why the growth and the demand was so great there. I think when you think back to the dot-com days, a lot of the work and the business done around that was purely for almost like startup companies trying to come up with the next greatest and best idea to deliver something that was mainly developed online, and it really attracted a lot of the IT graduates. But as you can see, what happened over that period, everyone heard of the dot-com crash of what occurred there. And I think what's happening now is that with all the movements towards things like sustainability, there's a lot of the core engineering degrees that are really starting to attract people back in. Those core skills are needed in engineering, but IT seems to now be an enabler to those, a lot of those industries, and it's required across the board. So I think there's a huge shift that people are starting to see that, hey, if I just have computer science and IT skills, I'm missing a huge opportunity in the employability market. Because every other industry nowadays needs those skills, but to have the core engineering skills puts you in a whole nother world.
Yeah, so I totally agree, and that's why we kept this session around the importance of core engineering branches. And if I look at suddenly when I think of civil engineer these days, what comes to my mind is like, is it a smart city engineer? Look at the Indian government's initiative around the smart city mission. They are focusing on 100 cities whom they want to be a smart city. So what is this smart city? We are hearing so much around that. When we say a smart city, like if I look at Delhi, is it a smart city yet, or are we in the process of making it a smart city?
Yeah, I think there's a real opportunity with the idea of smart cities. We can use AI and automation and, for example, if I walk into a building, we're using sensors and technology and the Internet of Things to try and make the environment within those buildings more comfortable for the occupants of those buildings, to help us with spaces and movement and just the way that things look and feel. And there's so much more that we can do with smart cities because the information can now start transferring, and we can start doing data analytics across things to make things more comfortable for people. But just coming to civil engineering, it's not just about smart cities. Within the smart cities, you have transport as well, which is part of that, right? So there's AI and automation and autonomous vehicles that we need to look at as well. But in civil engineering as well, we also look at things about water and how do we provide clean water to large cities to be able to provide the fundamental core infrastructure of what's needed.
Yeah.
So there's a lot of areas in civil engineering that's not just about building and smarts.
Yeah, so I remember I did my engineering. I'm a civil engineer. I did my civil engineering way back in 99, and there was a subject on transportation. Yes. But that time we were primarily into how do you maneuver the traffic? How do you make the flyover? How can you make all different types of flyover to make sure that there is less traffic congestion? But I think with the new generation, with what we are talking about, the driverless cars, we are talking about the air taxis. What do you think is the role of a civil engineer in all this new transportation system?
Look, a civil engineer will always be needed in the transport.
They'll always be needed, yeah. So guys in India have to look at that. Civil engineers will always be needed. Sorry, coming back to you.
Absolutely, they will be needed. I mean, if you go and drop out if you think that technology and advancement in automation and AI is going to take out a discipline like civil engineering, that's another thing coming. If anything, they're going to become in more demand. I mean, coming back to your smart cities thing, I look at the way that even a city like Sydney, I mean, I've been living in Sydney for the last 40 plus years. I don't want to give away my age all the way, but the way that the tunnelling that has occurred under the city and that people can move around the entire city in less than half an hour from one end to the other is phenomenal. Like if I look back in the last 5 years, it would take you potentially an hour and a half to get from one side to the city to the other. And now I've started driving electric cars myself. So I've just started driving a Model 3, and as I've put that into the auto drive to test it all out and how it's working, it's reading the signs around the road, it's moving through, but all of this stuff has to keep being reinvented, and there's always more to do. You know, the next thing, what's going to come? Driverless cars. Besides that, what about when we start moving through the air? What about when we start having Ubers that move us not through the road systems and the tunnels, or they start delivering us packages from Amazon? Like it's all coming.
Correct. So perfect. So we all understand there's a lot of demand around civil engineer will always be there. And parallelly, we have electrical engineers. Now, I know there was a time when we were wondering what will we do now, but with the focus on net zero 2050, everyone is talking about renewable energy.
Yeah.
Grids, which ensures that clean energy goes to even the rural of the places. So where is that shift in electrical? What are these guys going to do now?
Yeah, sure. So I guess the decarbonisation of the way that we generate our energy across the world is a really big thing. Now, there's many ways we can do that. You know, the things that people are talking about now in renewables would be the solar farms, the wind turbines. You can have turbines spinning underwater, but it's basically how do you move that energy across a country? And a lot of the times, if you have large solar farms, clearly you can't stick that in the middle of your big cities. You have to move that out into you know, very remote areas. And then you need the grids to be able to move that electricity around. So electrical engineers are really involved in that. How do we get smart grids to be able to do these things? How do we move that electrical capacity around countries? Because it's not necessarily the current grid systems that are capable to do that.
Correct.
You know, so we've got a lot of things to think about as we move towards, you know, net zero.
Yeah, so that's one, moving transitioning the clean energy. Also, when we were growing old, for us, cars were all about engines. Car was all about mechanical engineering, automobile engineering. And now we are talking about electrical vehicles. So we are talking about a car without an engine. So are we also saying that electrical engineers have taken all the jobs of mechanical engineers? There will be no more mechanical engineering and they'll be all about electrical?
So I'll tell you, Nikkhiel, there's very popular degrees that are coming up in, or disciplines within mechanical engineering now, mechatronics and robotics. So again, let's just think about Tesla for a minute.
Yeah.
I went on their website the other day. They've stopped working on cars, I feel. They're now starting to work on robots within the house that's going to walk around the house and do all the things for you that you might have had. Well, hopefully you might have been doing it yourself, or you might have had somebody else doing it for you. But the cleaning of your house, the unpacking of your dishwasher, the cooking of your food, we're looking at robots to do this type of thing. This is mechatronics. This is how we're going to, the way that the world is moving right now.
So yeah, I understand there's a lot of buzz around robotics. So from a student's perspective, do you think a plain mechanical engineering degree will work, or a combination of mechanical and electronics, which these days we call it mechatronics, will work? And is mechatronics sufficient enough to really help them become a robotic engineers?
Look, I think another great question. We're always going to have deep specialists in area, but there's also broad areas to work on. Now, you're going to, in particular businesses, companies, as you're working through things, if you are deep diving into one area, there's going to be a demand for you. But if you can start to link the different areas and, you know, almost project management across different areas, things like doing double degrees and broadening your horizons, and bringing more disciplines together can also be attractive. So I'm not saying that if you just do one specialist degree, that's not enough, because it can be, but you need to be deep. So there's room in the job market for deep. There's also a room in the job market for breadth.
So when we say breadth, are we suggesting that a student should do a dual degree, which obviously will be more than the stipulated duration of 4 years, can be 5 years?
Yeah.
But is there also an opportunity for, say, a mechanical engineer to pick up electives which supports the breadth, which makes sure that his degree has knowledge of other engineering streams?
Yeah, absolutely. So an important thing for us at UNSW Engineering and for many other universities is to get that breadth of experience. So even if you are doing a specialist degree, we have opportunities for picking electives, as you mentioned. There's also things for general studies. So I think one thing that really needs to be understood as well is that you also need to bring soft skills into your degree.
Correct.
You need to have that ability to be able to show leadership skills, to collaborate, to communicate. These are really important skills as well. Choosing electives in different areas, absolutely. You can go down and choose electives. You can do double degrees to get that breadth. You can also, at UNSW Engineering, we have a program called Challenge. And what Challenge is about project-based learning. And what we do there is we bring academics, industries, and students across different disciplines to work on student-based projects. Now, doing that, the skills that you gain from working on particular projects with cross-disciplinary members gives you those skills. So I'll give you an example of that. We have a solar car that we've been developing since 1996. So as the students go through, they keep adding to it, then they start again and start building a new one.
Okay.
The latest car we built is called SunSwift 7. That car is a cruiser class category, which can hold passengers in the back seat as well. We raced it from Darwin to Adelaide. Now, that's 3,000 kilometres of distance.
On solar?
On solar. Won the race, but that's a phenomenal thing that is all student built. Now, we have industry partners that get involved with that as well. So it broadens you to industry as well. As you
I
race in
heard
a car.
that car is in the Guinness Book of World Record also.
It
something
is.
like
You got it, Carl. Yes.
Yeah, that's the same one. Yeah.
And these are student teams that have been involved in this.
And when you say a student team, I come back to my previous question. Which all engineers worked on it?
Which engineers? So we had computer scientists, mechanical, electrical, students from the School of Photovoltaics and Renewable Energy.
So you have a different branch on renewable energy.
We have a whole school related to renewable energy. So the godfather of photovoltaics works in our institution. His name is Professor Martin Green. Look him up. He's an amazing man. But he has been working on the photovoltaic cell. He saw this long before anyone else did, that we needed to develop this technology. Now, this was a research group that started out of one of our schools of electrical engineering. The research group grew so big that it became its own school at UNSW. And that school now is continuing to advance the creation of the solar cell, but also now looking into the circular economy of what happens. Because after 25, maybe 30 years, what happens to that solar cell when it degrades? We don't want to just pick that up and throw it into landfill. We need to work out how to recycle the materials within that to regenerate the next solar cell and get that efficiency. So yeah, photovoltaics is its own school, and it's doing amazing things.
Yeah. Another thing, again, the importance why it's coming on core engineering branches. Now, we all knew that over the years, last couple of decades, China has always been the manufacturing hub. We started seeing goods made in China, and we all were so happy buying goods at much lesser a price, and hence we realized that all the manufacturing is going to China. And there was a time, I'll tell you, we were talking all the IT is coming to India. So this is how we used to compare. But now after COVID, what I realized, there's a lot of focus in India on Make in India, government's initiative. And we all could see that there was a news around Apple phones making in India, and we are now exporting it to the world. That's very, very commendable thing in India. But I think it's also happening globally. All the countries are now talking about make in their own country. What is going to be the change because of that?
Yeah, that's a really good question. So I think historically there was a piece to say, well, you know, as a business, how can I get access to labour to do some of these things? But every country, like Make in India, the scheme, Australia has one. The Australian government's released something called modern manufacturing. And the idea about that is, how do you bring manufacturing back on shore? Now, I guess one of the constraints has been in the past is around the cost of labour. But you can see as we start to develop these engineering disciplines, such as robotics and automation and robot arms, that's when the opportunities are starting to open up for countries to bring manufacturing back on site, because it's less reliant on labour,
Correct.
but more reliant on the skills of those university graduates out of engineering that know how to produce those automation and robotics. And that's where it's getting smarter, faster, stronger, more efficient, less variability in the products that are being created because it's less human touch. And it's a phenomenon happening all over the world. So being involved at that cutting edge and developing those production lines that is using automation and robotics is where manufacturing is going to start coming back into the countries where they start from, and that's the trend.
Yeah, that's the trend, and I think that's what all the parents there in India need to understand, that the trend is also now coming towards core engineering branches. So all you need to make sure that you know much in advance before you take those decisions for your children. Yeah, coming back to you, Lucian. So one branch which I thought I'll give my personal example. So my nephew, he did his chemical engineering from IIT Hyderabad. His name is Sandilya. He's currently in US, and then he studied his master's from Pennsylvania. And after his chemical engineering, but I'll tell you honestly, when he did chemical engineering from Hyderabad, I asked him, why did you pick up chemical engineering? I thought maybe he didn't get computer science, so he has picked chemical engineering. But he said, I'm passionate about environment. I really want to do something around that. So all said and done, that's like years back. But now, he's working with a company which is funded by a IT giant Google.
Right.
And he's working on carbon capturing. So he's doing what he was passionate about. Still, he's working with a corporate, a startup, which is funded by the world's one of the best IT organizations. So what is this all about? Why are these tech companies investing in small startups around sustainability? Why are they doing all that? And there's a lot of demand then obviously around chemical engineering.
Yeah, that's another great question, Nikkhiel. So look, from my perspective, so doing any discipline of engineering, and let's talk about chemical engineering for a minute, but I think what it is and what these big companies like Google are identifying is that when you do an engineering degree, you are able to look at a problem, approach it, and come up with novel ideas and ways to solve that problem. Now, companies like Google have problems, but they're looking for people that are real, true problem solvers. And sometimes it doesn't even matter about the discipline because they just know that training that they've been given behind allows them to do that assessment and come up with great ideas. Now, chemical engineers, besides the fact that they're in huge demand, because the way that we require, let's talk about battery storage just as a one-off, but the battery storage that we need around the world when we're generating energy and like something like photovoltaics or wind, not always the sun and the wind is running, so we need to store that energy somewhere and then use it when we need it, like at night. But the lithium batteries now are not the be-all and end-all. There's, new technologies that have to come in batteries like, say, solid-state batteries, and there's other mechanisms that we need where we can need fast charging. So, for one of, I'm jumping around a bit, but one of the pieces around an electric car is, a lot of people get something, I don't know if you've heard of this one, but it's called range anxiety. So when range anxiety.
Range anxiety.
They get range anxiety because when they're driving their car and that battery is running low and they're going on some big holiday somewhere and they need to fill up and they don't know if they're going to hit the station time, they get concerned. But then if you do, you've got long periods of time to charge that battery.
Correct.
So some of the companies that are producing charging technology now, like BYD, they're talking about plugging into the electric car and being able to charge that car in minutes, such as filling it up with fuel.
Yeah.
So, these are all stuff done by chemical engineers.
Oh, okay.
Which is phenomenal. Now, coming back to your example, I mean, I have a similar example. Like, there was an Indian graduate from UNSW. His name is Sandeep Chandra.
Okay.
Now, Sandeep, chemical engineer, industrial chemist, he now works for Atlassian. And he is now the strategy and operations manager of Atlassian with a chemical engineer degree. So these are very transferable skills. They're not just attractive to the engineering companies, but they're also attractive to the banking sector, the finance sector, the insurance. They are in demand.
Yeah. And again, coming back to my question of net zero 2050. What is net zero 2050? People are talking about that because of the climate change. We need to make sure that the carbon emissions are zero by 2050.
Yes, yes.
And yeah, so, this concept of carbon capturing is like the carbon which is already in the atmosphere. So why are companies investing in carbon capturing? Companies which are not into that, that's not their business.
Yeah. Well, look, I think a lot of these companies do have targets placed on them. So governments do place targets on those companies. So this is based off the Paris Agreement, which is to have a zero carbon emission by 2050. Yeah. And look, the primary driver behind that is there's concern that as the temperature, the core temperature in the world increases, that we'll get more disastrous events, so more natural disaster events occurring. And I think that the suggestion is that if you push the core Earth's temperature above 1.5 degrees up to probably 2 degrees, there's serious trouble for all of us. And I guess we're already experiencing it now, right? We're all experiencing it. Floods, cyclones, bushfires in Australia are rampant. These are big events that you could put onto the climate change that's occurring.
So now another question for most of the Indian parents and students. They all understand now, okay, there's a lot of demand around core engineering, but they always worry that if I'll do an IT or a computer science engineering, I will be well paid. But if I do a core engineering branch, I might not be well paid or I might not get a good job. So is that true? Or what's the global scenario like?
No, that is not true. I mean, we are constantly working with industry to understand where the demand is, and we want to make sure that we have degrees and specializations that cater for that. I feel engineering degrees are in very high demand. Now, there's some people that, yes, they absolutely want to do computer science, but I would encourage you to explore opportunities with double degrees in engineering. A lot of the engineering degrees have international recognized accreditation to them, such as the Washington Accord. And that means that these degrees are recognized when they're engineering degrees. They're recognized in places like the US, the UK, India, Australia. And having an internationally recognized degree is such a great foundation to have, as opposed to just having a pure computer scientist degree, which may be recognized in your country, but not necessarily something that's recognized around the world. The skills are in great demand, and there's always opportunities for double degrees into other areas.
And are there enough jobs? Like another thing for students here, when I visualize a mechanical engineering, I visualize myself working in a small factory. When I look at civil engineering, I visualize myself working in a site or a building construction site. But the aspiration for a student while he's in class 9, 10th or 11th is, I really want to work with a corporate wherein there are big buildings, there are big infrastructure. So do we have like a corporate jobs in the core engineering?
Oh yeah, absolutely. I mean, most of the big construction is all done by big corporates. So for civil engineers, like when I was talking previously about this LiDAR technology, when you can start mapping out buildings and actually measuring different areas to make sure everything's in line with the mathematics of that building. This is all civil engineering in big companies. There is huge demand for construction, but it's not just construction. I think a lot of people think civil engineers are just construction. There is so much more to civil engineering that needs to be considered, but it's a big industry.
Yeah. So again, from your experience or you're working with UNSW, what is that you really like doing, which you think is futuristic engineering? Which mankind might need in 10 years or 50 years from now.
Yeah, that's a great
question.
What
do you do at UNSW?
Looking into the future. Okay, well, I'll give you an example of what I'm thinking at the moment. So when you look at things like AI, so we have AI specializations, quantum computing, nuclear, all of these different disciplines, biomedical. So if you think about, so something in the future, 10 years, let's talk about synthetic biology cut into AI, into quantum computing and robotics. Now, if you start thinking something like that, there is a whole new industry that we haven't even thought of yet that can bring amazing things together. We may be even able to grow complete body parts for people.
Complete body parts?
Why not? Why not? The AI, when you're talking about synthetic biology, in the AI that can come up with so many more combinations of how things can be grown with the DNA structures, who knows what's possible? So at UNSW Engineering, next year in our Bachelor's of Engineering undergraduate degree, we're launching a specialisation in biomedical engineering. This is starting to set younger people up. Before it was just for the graduate school, it was only postgraduate degree. But this is starting to set people up for how can I combine biology, an undergraduate specialisation in biology, with AI. We have quantum computing researchers in our university now, Michelle Simmons, Andrew Zurak. These guys are working on the quantum computer right now.
So coming back to the basic question, when you're talking about a degree like this, bio and AI, do students need mathematics to join this degree?
Yeah, look, mathematics is a core. It's a very good thing to have. Now we can always help people that haven't done in their high school the level of mathematics required with bridging courses. But generally, you were saying if you're a year 9 to 10 student now, you would be looking at making sure you have some of those STEM disciplines in your high school degree to make it easier to transition into that.
So what normally happens here in India is normally a student who wants to become a doctor, they will do physics, chemistry and biology. They'll not pick maths. Some might pick maths, but primarily they will have a biology degree, biology subject without mathematics. And because you mentioned about bio and AI, so I was wondering whether such students will be eligible for a degree like that.
There is bridging courses. There are things that you can do. You might have to do some extra work prior to getting entry.
Okay.
Or if there is a lower level of maths, there is other support that is available to get into that degree. So it's not a hard prerequisite on that. We're trying to keep this open. But you'd want to be doing that prep work because going into first year and having to do maths 1A, 1B, statistics, with zero mathematical background will be very challenging if you haven't done that something prior to that. So,
got it.
But there are avenues and channels. But if you have the opportunity to do that in high school now, then please consider putting mathematics into your subject
So
choices.
I think everyone is listening to that. Maths is important. Not that it's everything, but it's important. If you can't do it, you should do it. So coming back again. So there are terms which are used these days in universities like factory of future. I even heard recently a term like microfactory.
Right.
Yeah. So any ideas around what are those terms like?
Microfactory. No. Tell me more. What do you mean by the microfactory?
Yeah. So microfactory is primarily, I just heard a term that it's more around they're trying to do more around the sustainability.
Oh, right. Yes. Yeah.
So
I think across all of I would say a core element of engineering is around decarbonisation and sustainability. There is a huge part of it. And when I look across the 8 schools of engineering, including computer science engineering, there's data analytics and things that have to happen on this too. I think everyone has a piece that they can play in decarbonisation and sustainability for our environment.
Great. Thank you so much. So, Lucian, I keep on hearing these terms like factory of the future, wherein they talk about that machines will talk to each other and get the work done. There might not be any need, not any minimal need of a human intervention. But suddenly these days, I've also started hearing about this term microfactory. Now, what is this microfactory at UNSW?
Yeah, thanks, Nikkhiel. Yeah, so we've got an amazing researcher, Veena Sajawala, and she has a research centre, the Smart Centre. And I guess what Veena really looks at is there's so many waste materials that are occurring all over the world. And an example of this is the tyres that come off cars. Once the tread wears, they come off cars, they end up in landfill, and it's just a complete waste of resources. And what someone like Veena's done is she started to explore the idea of these microfactories. And microfactories are really about how do you take these waste materials, break them down, and turn them into something useful. And what Veena's managed to do is turn them into green steel, turn them into ceramics, useful products that can be reused in the world. And I think as a student, we need to start thinking about more and more about this. We need to start thinking about that cycle of materials. It's not just about taking them from the ground, making them to something and then throwing it back in the ground. Continuously look for reusable uses of these materials.
Great. Now, one last thing, maybe again from your experiences, what is that one example you can give for these young kids of class 9th and 10th, which tells them that sky is the limit when you want to think what you want to achieve?
Yeah, we've got some amazing researchers at UNSW. One of them, as an example, Andrew Dempster. Andrew is somebody that believes that one day we could be living on Mars.
Okay.
And in order to get there, we have to go via the moon, as that's the closest spot.
Yes.
So he's come to me and asked me, can we invest in this lab at UNSW, which is replicating a moon?
Replicating a moon?
Replicating the moon, like the materials and what have you, so they can actually experiment. And I think what the main thing that Andrew's trying to work through in this lab is, how is it life needs water. So as a transition to Mars, if we can get to the moon and work out how to extract water from the moon and generate it, then it potentially becomes a livable space. And then if we can make the moon a livable space, does that mean that that's our next step over to Mars? So there are thought processes out there.
Yes.
It could be endless.
Yes. And I think the advice to the students will be, real work is happening in the universities, and while they are thinking what they want to achieve, I think sky is the limit. Whatever they think, they need to be with right mentors who handhold them and nourish their ideas so that they can really do well. So we'll end it here. But before we end it, any one piece of advice you want to give to these kids?
Yeah, there is something. I think, during this discussion, we've spoken about what the future is. And I guess at the end of the day, we're both guessing.
Correct.
We don't 100% know where things are going. But I think the important thing is, no matter what kind of engineering degree you do, as long as you learn how to learn doing these degrees, the content will provide you with a solid foundation, but it's not necessarily what the job is you'll be doing in the future. I can almost guarantee you the job you will be doing in the future does not exist today.
Correct. That's a very important point which you have made. We all might be chasing something which might not exist in 10 years.
It might not exist, but if you learn how to learn, the world is your oyster. You will be able to adapt, adjust, and find new careers. You'll be employable.
So the final word is learn how to learn.
That's it.
Thank you so much. I think we'll end with this. Learn how to learn, guys. All the best for your careers. Thank you so much, Lucian, for being here.
Cheers, Nikkhiel. Great to be here.
Cheers. Thanks.